So we're going to finish up material for the week. So we started looking at 4.1 yesterday. The main thing we learned there was the 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. Today, we're only going to be using the first 3, sine, cosine, and tangent. And the reason we're going to focus on using those 3 is because when we use a calculator, those are the 3 that you have buttons for. So they're the easiest ones to use. And the goal of what we are doing today is right there, solving triangles. Okay, so when you are asked to solve a triangle, they'll give you a problem, something like that. You have to figure out how long all the sides are and how big all the angles are. So there's 6 pieces of information, 3 sides, 3 angles. We're working with right triangles. So what's something that we know about every triangle that we're going to work with? It's going to have a 90-degree angle. So there's 1 out of the 6 things that you're already going to have in every single problem. One angle will be 90. We're going to come back to solving triangles again in 2 weeks, and we're going to do it without a 90. But for this week, every problem will have a 90-degree angle. In order to solve the triangle and figure out everything else, I have to give you more information. Okay? I can't just give you a 90 and say solve the triangle. You need 2 other pieces of information. So I either need to give you, in addition to the 90, one of the other sides and one of the other angles, which is what I'm going to do in this first problem. I'm going to give you one of the sides, and I'll give you one of the angles. Or I can give you both the sides. And that's what I'm going to do in this problem. I'll give you that side, I'll give you that side. But I didn't give you any of the other angles. Depending on which of these 2 cases you have, we have to go about solving it a little differently. But you will have each case on the test. At least one of each. So what's going to help us to solve it? We're going to draw a picture, and we're going to make a table. The picture is so we can visualize what's opposite and what's adjacent. After you've done a few thousand of these, you can kind of visualize it in your head. But at first, it's helpful to maybe make a picture so you can see it on paper. That's opposite, that's adjacent. Then, just for organizing our answer, we're going to put everything in a table that looks like that. We'll have the 3 sides going on the left. We'll have the 3 angles going down on the right. All right, so now we'll start to look at an example. There's a couple more things I'll mention as we do the example. But that's pretty much all you need to know going into it. Any questions so far? Okay. So first one we're going to do is this one. I'm going to give you a side and I'm going to give you an angle, and you have to figure out everything else. All right. So there's the 2 pieces of information. What's the first thing I said that we should do with those 2 pieces of information? Yep, we're going to draw it. So remember, when you draw a right triangle, it doesn't matter which way it faces. If you want to draw your triangle facing this way or any other way you want, that's fine. I usually draw them like that. What do we label the sides as?
ABC.
ABC. And the A and the B are the what?
Legs.
Those are the legs. Now, you don't have to use ABC. It'll probably be simpler if you do, because we're used to ABC with Pythagorean theorem. But they're just names to represent sides we don't know. But A, B, and C is traditionally what we use. And now for the angle across from A, what is the name we use for that one? Not theta. It is a Greek letter, though. We don't usually use theta here. You could, but we use something different. Yeah?
Alpha.
alpha, because A is the first letter in the English alphabet, alpha is the first letter in the Greek alphabet. So we put A and alpha across, and anybody remember the letter we put up here? Beta. So that's your generic diagram you're going to use for every problem today. Now I'm going to fill in two of the pieces of information. I'm going to make, you don't have to cross it out, but I'm going to put that as a 2, and I'm going to put alpha as 40 degrees. Okay. So now I've got my picture. I can see what's opposite alpha, what's adjacent to alpha, and what the hypotenuse is. So now put all that in a table. In the table, I've put boxes around everything that we don't know. And everything that we do know, I filled in. So the goal is to figure out these three pieces of information. A, C, and B. You can find any of those pieces of information in any order you want. Doesn't matter. I tend to do the one that I think is going to be the quickest first. Anybody see, out of these three, which one do you think we could find pretty quickly? Yeah, we can find beta very quickly because we already know the other two angles. So this is 90, and we said yesterday that the other two also have to add up to 90. So what does that mean beta is going to be? 50. That's the easiest thing we're going to find. So now we know beta is 50. Any questions how we got that? All right. So now we have to find A and we have to find C. Doesn't matter which one we do first, but we do need to pick one. So which one? A. All right. We're going to find A. Okay. So to find A, we're going to pick, and I'll put some notes in this problem. I'm not going to do it for everyone, but just the first one I will. We're going to pick a trig function. You have three choices: sine, cosine, or tangent. Do not use secant, cosecant, or cotangent. Okay, so we're going to pick one of those three. And the way we're going to figure out which one we need to use is we're going to look at the information that they gave us, and we're going to figure out, well, what side do we know, and what side do we want to know? The side that we know right now is the bottom side. What position is the side that's 2 units long? We have the choice of opposite, adjacent, or hypotenuse.
Adjacent?
It is adjacent. Yep. We're using that angle. The reason we want to use the 40-degree angle and not the 50, well, anybody know why? This is a better angle to choose than the 50? Because you could do it with the 50, but I would stay away from the 50 for a very specific reason.
Is it because A is opposite to 40?
It doesn't have to do with the position of anything. No, it doesn't have to do with where things are. But where did the 40 come from? It was given to us. So why would I want to stick with using it? We know it's right. Okay? So if you use the 50, if it's right, then yeah, the problem will come out fine. But if you made a mistake finding this and you use it, then everything you use it for is also going to come out wrong. So when you're doing a right triangle problem, don't use anything that you calculated to find something else. Okay? Always use what was given. So I'm going to circle the two things that were given, the 40 and the 2, and I'm going to circle what I'm trying to find. So there's always 3 things involved: 2 sides and 1 angle. That's how these trig equations always work. So we just said that this side was adjacent. And what is the position of the side that is labeled A?
Opposite.
That is opposite. So the 2 sides that are involved in finding A are the opposite and the adjacent. Out of these 3 trig functions, there's only one there that would use opposite and adjacent. Which trig function is that? Tangent. Yep. So we're going to use tangent. Leave room to fill in your angle. And then you're going to have a fraction on the other side. That's how every equation is going to look today. It's going to have a trig function, leave room to fill the angle into the trig function, and then a fraction on the other side. Okay. What's the angle that we're using in that triangle?
40 degrees.
40 degrees. So the tangent of 40 equals, and what's the definition of tangent?
Opposite over adjacent.
Opposite over adjacent. A over 2. So there's your equation. Last step is to get A by itself. So the reason A is not by itself is because it's being divided by 2. You've got to get rid of dividing by 2. So we would multiply by 2 and multiply by 2. So that is the answer for A. We do want to type that in. Okay, all of these problems we're going to round to 3 decimal places. Okay, what's the first thing I should do on my calculator? Set it to degrees. My calculator is in radians. If I type in 2 tangent 40, it'll give me an answer. That answer doesn't make sense at all. How can you tell that that answer does not make sense? It's negative, right? We're finding the length of a side. How can the length be negative? Something's wrong. So we get changed to degrees. Every problem we do today is degrees. Right? So change it to degrees and type in 2 tan 40. I'm not saying every problem on the test is going to be for the whole week is in degrees, because we did radians earlier in the week. But for the problems you learned today, these kinds of problems will always be degrees. And that's it, 1.678. So that is the length of A. All right, so now we've got 2 out of 3 of the sides. What could you do to get the third side? You could do Pythagorean theorem, but why do you think I'm going to say that's not a good idea? Right, because you found this side, so if this is wrong, and you use it to find C, then guess what? You just got C wrong. Right? So we're going to find C the same way we found A. So what that means is if you make a mistake on one part, it will have no effect on anything else. You could still get the other 2 out of 3 parts right. Okay. So now let's find C. So I'm going to circle again the sides that we're going to use. We definitely want to use what was given. That's the 40 and the 2. And this time we want to find C. Okay. So focus on the 3 things that are circled in red. Well, I know the side that's 2 units long is adjacent. What's the position of the side that's called C? Hypotenuse. Okay. So now let's write down how we're going to find C. All right, so we're going to have a trig function, fill in an angle, and a fraction. We got to figure out the trig function. In this case, it will be cosine, because the adjacent is the side we know, hypotenuse is the side we don't, and those are the 2 sides, adjacent and hypotenuse. And the only trig function that has those 2 that we're using today is cosine. Okay. Any question why we picked cosine?
Why aren't we using the other 3?
Because we don't have buttons for them on the calculator, so we could use them, but it would be more steps. So we're going to stick with the ones that every calculator has a button for.
But hypothetically, you would be able to use the other ones too.
Yep. All right, so we've got cosine. Now we have to fill in the angle. What's the angle in this problem? 40. That's called your reference angle. It's your point of reference where you're standing in the triangle to determine opposite and adjacent. So it's called the reference
Would
angle.
you be able to use the 90-degree angle?
No. Nope, you can't ever use the 90. When you're doing trig, you have to use the angle that's not 90. Always. And again, this is the better one to pick because it was given. If you use beta, it can work as long as you're 100% positive you got beta right. But I would just stick with what was given. Okay, so we've got our angle, and cosine is adjacent over hypotenuse. What's the adjacent in this one? 2. And the hypotenuse? C. 2 over C. So this is the other kind of equation you can get. The first one had the letter in the top. The second one has the letter in the bottom. We're still going to start out by doing the same thing. We don't want to have a fraction. Okay? So how would we get rid of having a fraction on the right side?
Multiply by the reciprocal.
There's something I can do that would be simpler that would just get rid of the fraction. If we multiply by the reciprocal, you're still going to have a fraction on the right. Well, you're going to still have more work to do. We'll leave it at that. Just times by C. Times by C. Times by C. What that gives you on the left is C times the cosine of 40 degrees. And on the right, what are you left with? Just 2. So now we don't have a fraction anymore. We still don't have the letter by itself, but at least we don't have a fraction. Now, how would you get this C by itself? Divide each side by the cosine of 40. Okay, what is the cosine of 40? We don't really care. We just have to divide each side by it. So I'm going to let the calculator figure out what the cosine of 40 is. I don't want to type that in and round it off right now. So this is gone. And there's your answer for C. 2 divided by cosine 40. So if you notice what happens in this kind of problem, this was the original problem inside that purple box. All that's going to happen every time when you have a letter in the bottom is these two switch. So the C and the cosine 40 are going to switch places. And that's why it ended up in the bottom.
And that's your final answer.
If we type that in, and that's our final answer.
So you want the decimal.
I want the decimal. Yep. So I'm not going to go through the steps of multiplying each side by C again and then dividing by cosine 40. I'm just going to take this shortcut and switch what's in the bottom and what's on the other side. And that works in any fraction, always. Even if it doesn't have to be trig. If you got something like 3 equals 5 over x, and you're trying to solve that, that's exactly the same thing we have up above. You can just switch those two. But it only works with that exact kind of problem that you can switch those two. If you start adding something over here, no, you can't do that anymore. It has to look exactly like that. All right, so let's see what we get. 2 divided by cosine 40. It's not important that I close the parenthesis because I don't have anything coming after it. So 2.611. Let's see.
Does it have to be in 3 decimal places?
For these, yeah, we're going to generally go with 3. Unless the directions tell you you can do a different amount. But if they don't say, go with 3.
Okay.
So if this was a problem on the test, if you had an answer like 2.96 or something, that's not right. Right? You should be getting something where 2.611. You shouldn't be getting 2.8. You shouldn't be getting 2.4, unless you did something wrong or you rounded something you weren't supposed to. There's no reason why you shouldn't get exactly 2.611. All right. Any question on that? So now, if I had an extra 20 seconds and I wanted to double check that I did that problem right, I could try Pythagorean theorem and see if it works. And if I get the same answer, then I know I did it right. Okay. Take 1.678, square it. Take 2, square it. That's a squared plus b squared. And that's supposed to equal c squared. If it does, then we did it right. That's c squared. So when we did a squared plus b squared, we got 6.816 if you round it, and the other way we got 6.816 and 6.817. Well, they are a little bit different. And why is that?
Around in the first place.
Yeah, it's because these two are rounded. But yes, basically a squared plus b squared did equal c squared. We did it right. Okay. Any question on how I checked it? The other thing that you can always look at quickly is the biggest side always should match up with the biggest angle, and the shortest side should match up with the smallest angle. If that doesn't happen, then something is definitely wrong. It's something you can check very, very quickly. So let's try one more where I give you a side and an angle, and then we'll try the type where I give you two sides. Okay, I'll give you guys a couple minutes to try that one. Okay, so remember you can find anything you want in any order you want. But I would definitely draw a diagram first so you can visualize what's opposite and what's adjacent. Okay, so take a few minutes and then I'll kind of check in with you, and if people have questions, we'll go over it together in just a few minutes. All right, so let's start to take a look at this one. So this time they've given us the information. They've already put it in a table, so we don't have to set up that. But what should we do first with that information?
Find alpha.
Even before we do that,
Draw it out.
yep, let's draw a picture of it. We might not need the picture to find alpha, but the picture is going to be helpful for the B and the C. So draw a picture. I'm going to put A at the bottom, which means alpha needs to go across from it at the top. I'll put B on the left side, which means beta goes across from it on the right. And C, that's always going to be the hypotenuse. We never want to make that one of the legs. Always keep C as the hypotenuse. Okay, so the suggestion was let's find alpha first. All right, what is alpha?
70 degrees.
70 degrees, yeah. Because we know that alpha and beta are going to add up to 90. So 20 plus what gives you 90? 70. Okay. So we've got alpha. And which side do we want to try to do next? B or C? B? Okay. So to figure out B, we need to choose a trig function. And we need to label all of the sides and their positions. Right? So the 6, we're going to use that because it was given. The 20, we're going to use that because it was given. And we decided we're going to find B. So we have to use that because it's what we chose. Okay. What's the name of the side that is 6 units long?
Adjacent.
That is the adjacent. What's the name of the side, or what's the position of the side that's labeled B?
Opposite.
That's opposite. And the position of the side that's labeled C? Hypotenuse. Okay, we're not dealing with hypotenuse right now, but we will when we finish the problem. Okay, so what are the two sides that we're going to use right now?
Adjacent. Opposite.
Yep, we're using the opposite and the adjacent. And what trig function has those two?
Tangent.
Tangent. So tangent, angle, fraction. What's the angle that we're going to fill in to tangent?
20 degrees.
20 degrees. And the definition of tangent is opposite over adjacent. So what's going to go in that fraction?
B over 6.
B over 6. And how do we get B by itself?
Multiply by 6. Both sides.
Multiply both sides by 6. So again, make sure you are in degrees, and we should be from last time. So 6 tangent 20. So we get 2.184. Okay, make sure you round properly. 2.184. Okay, so the only thing we have left now is C. So let's find C. So now to find C, we're going to still focus on the two pieces of information that we're given. But now we're going to find C instead of B. What two sides are going to be involved this time?
Which is just hypotenuse.
Right, the given and the one we're trying to find, adjacent and hypotenuse. And Jaden, what trig function has adjacent and hypotenuse in it?
Cosine?
Cosine, yep. So cosine, leave room for your angle, and put your fraction. Okay, what is our angle again in this one?
20.
20. So put in your angle. And cosine is adjacent over hypotenuse. What would it be? 6 over C. Yep. And what can we do quickly to get the C by itself?
Switch them.
Yeah, switch the 6 with
The cosine.
the cosine, right? So you have C equals 6 over cosine 20. And now just type that in. So 6 divided by cosine 20. So 6.385. That's it. So any questions on solving that one? All right. So that's the type where you're given a side and an angle. So let's look at this type. So now you're being given two sides. So A is 3, B is 2. We have the right angle, and then everything else we need to figure out. Pretty much the same concept. Don't use anything that you've calculated to find anything else, because if you make a mistake and you use something that's wrong, you're going to mess up everything else. And you can find anything you want in any order you want. Those two things still apply. What do you want to try to find first? C?
C.
Alpha or beta?
C.
C? Okay, so let's find C. How could we find C?
Pythagorean.
Right, we could use Pythagorean theorem. How come I'm okay with it this time, but I wasn't okay with Pythagorean theorem last time?
Both the angles are given to us. Or both the legs are given to us.
Right. Both of the legs are given. So when you use Pythagorean theorem, you're not filling in something you found. You're filling in what they gave you. So that's fine. So A squared plus B squared equals C squared. 3 squared gives us how much?
9.
And 2 squared? And what's 9 plus 4? 13. And now we've got to get rid of the function that's squaring to C. So what function cancels that out?
Square root.
Square root function. And because we're rounding, we will put that in. So the square root of 13, 3 point something? 3.7, 3.6, 3.606. Okay. So now we've got C. Should we use C to do anything else? No. So we have it and forget about it. Don't use it again. All right. What should we do now?
Alpha.
Okay, so we're going to find alpha. What's going to help us to make finding alpha easier? We're going to draw it out. So you're going to draw a diagram. And in your diagram, only write down things that were given. Then you're not tempted to use something that you found. Right, so I was given A. I'm going to put that down here. So alpha will go across. And I was given B. So beta goes across. C, I do know it, but I'm not going to label it and that'll remind me not to use it. Okay, so these are the two things we always want to use. And what angle did we decide we're going to do, alpha or beta first? Alpha? Okay. So let's find alpha. The equation is going to look very similar. You're going to have a trig function, which we don't know yet. We can fill that in. Leave room for your angle. And then you're going to have a fraction on the other side. All right, and we're doing alpha. Okay. What is the name of, or what's the position of the side that's 3 units long? That's opposite. And the position of the side that's 2 units long? Adjacent. And that's all I need to label, because I'm never using C in this problem. Just need those two. Okay. What trig function has the opposite and the adjacent? Tangent. So it's going to be tangent of, and what's the angle that I'm going to fill in? Alpha. That's the big difference in this kind of problem. The variable is not going to be in the fraction. It's going to be right there. It's right inside the trig function. So we've got tangent alpha equals, and what's the fraction on the other side? 3/2. Now, this looks very similar to one of the answers you would have written in the homework last night. Right? When you did all 6, you did the sine, the cosine, the tangent, secant, cosecant. This is one of them. Tangent alpha is 3/2. But I don't want to know the tangent of alpha. That's what I did yesterday. I want to know alpha. So I have to somehow get rid of tangent. How am I going to get rid of tangent? Right, the inverse of tangent. Right? Tangent is a function. It's a word. You can't divide by tangent. You can divide by a variable, or you can divide by a number, but you can't divide by a word. But what you can do is you can do the inverse of that. So we're going to take the inverse tangent of everything on the left, and we're going to take the inverse tangent of everything on the right. Just to be clear, there is 0 multiplication happening in that problem. No multiplication. We're just taking the inverse tangent of both sides. Just like if you had something like this. You wouldn't say multiply both sides by the square root. You use square root, but multiply is not the right verb. It's just take the square root of both sides. Take the inverse tangent of both sides. That's how you say it. And what happens on the left when we do that?
You just have alpha left over?
We just have alpha. It's like if I have x squared and I square root it. You just have x. Everything else cancels out. Well, here our letter is not an x, it's an alpha. So we have alpha equals the inverse tangent of 3/2. So now we have to type in inverse tangent 3/2. So second inverse tangent 3/2. So that gives us 56 point, that's going to round up to 0.31. And what did I just solve for? Alpha. And what is alpha in the triangle? It's degrees, and degrees is used to measure angles. We just found an angle. So we have to make sure we put a label. 56.31 degrees. It's actually 310. Okay, if you forgot the degree symbol, you'd lose a little bit of credit. If you got the 56.31, that's good. But you got to put the degree symbol. All right, so now, since I have 2 out of 3 of the angles, could I just add the 2 I have together and subtract from 180? I could, but yeah, we shouldn't. How come? It wasn't given. So if you add them up and subtract from 180 and you got that wrong, well, now you're going to get that wrong. So we're going to find beta the same way we just found alpha. So we're going to have trig function, our argument, and then we'll have a fraction on the other side. Okay. So we are finding beta. So let me circle what we're using now. We're still using the 2 that was given. We're still using the 3. But now we're using beta. What's going to happen now that we're using beta?
You're just going to flip 3 to 2.
What do you mean, what's going to flip? I mean, the 2 is going to stay where it is, and the 3 is going to stay where
But
it
yeah,
is.
but once you write it out, in order to find beta, you're just going to do the inverse of tangent 2 over 3, and that's going to give you your answer.
How come?
Because it's still opposite over adjacent, but you're looking at it from a different
Right.
position.
We're looking at it from a different reference point. These names no longer apply. Okay. That did not happen in the last 2 problems because we never switched the angle we were using. And the reason we never had to switch it is because it was given. So we always want to use the given. Here, the angles were not given. So you have to switch your reference point. So now this is opposite, beta, and that is adjacent. So you are still using opposite and adjacent. So it is the same trig function, but they switch places. So we're still using tangent. And the definition is still opposite over adjacent, but that's 2 over 3. So 2 over 3. And the angle we're finding is beta. Okay. And how do we get beta by itself there?
Inverse tangent.
Yep, take the inverse tangent of both sides. That gives you beta by itself on the left. And now that's what we're going to type in. Okay, so let's do inverse tangent of 2/3. Okay, so we get 33.690. 33.690. Now, if we did everything right, you could check it by adding up all the angles on the right side. And if you add alpha, beta, and the 90, you will get 180 in this case. Okay, you might get 179.9 sometimes because you round. But in this case, that does add up to exactly 180. And that's because we use 3 decimal places. It's a little more accurate than using 2. Okay. So any question on this second type, where you have 2 sides? So whenever you are given this kind of problem, you always have to use inverse trig. You can't do a 2-side problem without inverse trig. The first type, you never use inverse trig. Only for the second type. Also, the second type is the only one you should ever be using Pythagorean theorem with. You shouldn't do Pythagorean theorem with the first type. Okay, any question on the difference between the 2? All right. So I'm not going to go through this whole problem, but if you were going to solve it, would this be a problem you need inverse trig for, or no?
Yes.
Yes, it is. You would need it because you're given 2 sides. You have to figure out the angles, and that's what inverse trig is for. Inverse trig calculates angles. And you could use Pythagorean theorem. But again, I'm not gonna go through that. All right, let's try last one. So this one says that you are leaning a 20-foot ladder against a house, and the angle between the ladder and the house is 17 degrees. How high is the top of the ladder? So anytime that you are given information like this, what would help you to make that a lot easier to understand?
Write it out.
Write it out?
Yeah, like draw it.
Well, draw it out. Yeah, so it is written out. Right? There's all the sentences, but I would draw it out. And when you draw it, the hope is, if you do it right, you're going to end up with what kind of shape somehow in your drawing? A triangle. You're going to end up with a triangle in your sketch somewhere. So, what is something important that we need to draw in this picture? I'm not worried about numbers. I'm worried about what objects. need to be in the picture?
The house and the
The house and the ladder. And there's one more kind of default object you need to have.
ground.
You need the ground. Without that, you don't have a house to, anything to put a house on. So we've got the ground. Okay, we've got house over here. And we have a ladder leaning against the house. Let me fix that. So maybe something like that. It's a ladder leaning against the house. And that's pretty much all the objects that we have. Now, in order to do this, we do have to assume that the house was built perpendicular to the ground. If it wasn't, then we're dealing with a problem like the Leaning Tower of Pisa. That would be different. That gets a little more complicated. But this house was built perpendicular to the ground. What else do I know that I can label in that picture?
17 degrees at the top.
Right. It says the angle between the house and the ladder is 17 degrees. Now, if it said the angle between the ground and the ladder, that's the ground, that's the ladder, that would be over there. Okay, but this is the house and the ladder. So we got the 17. And what else do we know?
20 feet.
What's 20 feet?
The length of the ladder.
Length of the ladder. So that's 20 feet. So here is the triangle that you're working with. Okay, the triangle itself, that should be secondary in your drawing. You shouldn't be thinking about drawing a triangle. You should be thinking about drawing the objects in the word problem, and then a triangle should just happen. Right. And what is it that we're trying to find in that blue triangle? So what would that be in our diagram? One, yes, it is one of the legs. Which leg? The one by the house, the vertical leg. So we have a vertical and a horizontal. You want to find that. Since it's a leg, you could call it A or B. It doesn't matter. But here's the three pieces of information that you're going to use. So look at the three pieces of information you're being given. Is that going to make it more like the first problem type or the second? Yeah, this is the first type. I'm giving you a side and I'm giving you an angle. So are you going to need inverse trig? No. You're not solving for an angle. You could figure out every angle if you wanted to. They don't want you to, but you could. You don't need inverse trig. Anybody know what trig function we're going to use? All right, let's try cosine. So it's cosine. I filled in the angle because that was what was given. And cosine would equal, what would your fraction on the other side be? A over 20. Adjacent over hypotenuse. And then what's the last thing we would do to get A along?
Multiply both sides by 20.
Yep, multiply both sides by 20. And now we'll type that in, and that will tell us how high the ladder will reach. Now the ladder was 20 feet. If you put a ladder on an angle, that means it can't reach as high. So it's got to be less than 20 feet. Right? Maybe it's like 18 or 19 feet. 20 cosine 17. So it's 19.13 feet. So the question was really, where would the top of the ladder be? It's not necessarily where would somebody standing on the ladder be able to reach, because you could reach a little higher, depending on how tall you are. But we're just talking about where the top of the ladder would rest against the house. That's it. Okay. Any question on that? So that finishes up everything for this week. Right, so that's the homework for tonight. And we've got about 20 minutes, so please take the time to try to start that. What I'll do now is I'll pause it and I'll put all the test topics on the board, and then we can see if anybody has questions on the test topics.